Greetings, this is Anthony Dick, just making a recording walkthrough this Frappy 2003B problem number 1. A simple random sample of 9 students was selected from a large university. Each of these students reported the number of hours he or she had allocated to studying and the number of hours allocated to work each week. A least squares regression was performed as part of the resulting computer output shown below. Okay, and I've got my constant. Remember, that's the y-intercept. I've got that. This is my slope. Never use this. Standard deviation of the residuals there. R squared value, I can take the square root of that and get my R value. And this stuff is stuff we haven't used yet, but we'll use it later, but not in this unit. Scatter plot below displays the data collected from the 9 students. 1, 2, 3, 4, 5, 6, 7, 8. And this dude out here. Wow. It says after point P on the graph was shown the previous page was removed from this data, a second linear regression was performed and the computer output is shown below. Does point P exercise a large influence on the regression line? Oh, sorry. So I'm looking down here. So after point P labeled on the graph, so that one up there, was removed from the data, a second linear regression was performed and the computer output is shown below. Does point P exercise a large influence on the regression line? Explain. I think yeah. I can say yeah right now because it's gonna strengthen that pattern going up there. But so let's look. We'll see what happened, and let's look at everything. Look, the y-intercept changed. The slope went from 0.49 to 0.15. It changed, and the R squared value went from 47.6 to 2.5. Yeah, that made a huge change. So the answer is yes. And how do you know? I would say everything. The y-intercept, increased, went from 8.1 to 11, increased from 8.107 to 11.123. The slope decreased from 0.4919 to 0.150, and the R squared decreased from 47.6% to 2.5%. 47.6% to 2.5%. So did it have a large influence? Yes. Had a big influence. How do I know? Because these 3 things changed. If you say it has a large influence, you better know what changed. Okay, cool. Flip the page. The next one. Okay. The researcher who conducted the study discovered that the number of hours spent studying reported by the student represented by P was recorded incorrectly. The correct data point for this student is represented by the letter Q right there in my scatter plot. Explain how the least squares regression line for the corrected data in this part would differ from the least squares line for the original data. So my original data was here. How would that change? And how would it change the least squares regression line? Well, think about it. The point P was up here, right? And it was described as that. But look at this. See the pattern? Wow, what would change? My slope. Would it become negative? I'm not sure, but the slope of the least squares regression line, and I can use that abbreviation, would change it would decrease definitely, but I think it would become negative because that's a positive slope. But with this, look, this really is, that would be a negative slope. There's got to be a negative slope. Because, see, this is my original bubble, like there, and this is my new bubble. See that? The new bubble's negative. So it would decrease, it would change, but it's not, I want to say how it's changed. The slope of the least squares from line would change from positive to negative, and the y-intercept would change from somewhere down here to somewhere up here. The y-intercept would increase. Okay? So the least squares regression line is a line, so it has a slope and a y-intercept. I want to say how each of those things would change, because that's what it's asking. That's it, guys.